That's what we've got on the book. We're going to find some perimeters of some different polygons. And of course, I have a little bit of vocabulary, but I'm pretty sure you know maybe like already what an octagon is. You had to guess it? So I have faith in us. So here we go. Let's just first kind of review and get ready because there is some distance formula involved today. Find the length of a segment with the endpoints. Now, when it says length of the segment, because we're going to have to use this for today when we do our formulas. How long is a side of a triangle? I need my distance formula. And you guys really crushed distance formula on the quiz. I don't know if you remember that problem on there. It was really good. So I'm going to label, of course, x1, y1, x2, y2. And let's just plug it in. And I did, obviously, the formula's at the very bottom on the board up here. It's still up here in front of you if you need it today. All right, x2 minus x1 squared plus y2 minus y1 squared. And I'm guessing you're going to make that a plus. I would too. Let me give you a second. Punch that in your calculator, and we're going to round it to 1 decimal place. Testing the calculator skills. So like I said, today is easy, just a lot of calculations. So the most time-consuming thing you got to do is some distance formula. All right, round it to 1 decimal. Testing it. Like it, like it, like it. All right, we got it, we got it. You should have 4.1. Any questions on typing that in? Okay. All right, next up. Okay, this is also easy. Stephanie wants to lay carpet in her family room that's 12 by 15. How much carpet does she need? Are you finding the area or the perimeter if you want to cover it in carpet? Area. So area of a rectangle, length times width. All we have to do is 12 times 15. Punch that in. What's 12 times 15? 180. I'm going to get fancy on this one and throw on a label. That would be, since it's area, feet squared. Good. So I am going to label our answers today, our area answers. I'm going to use squared, feet squared, etc. Obviously, we don't need that for our perimeter. So here we go. Vocabulary. There is absolutely nothing for you to write in on the note sheet. This is all on there. We're going to talk about polygons today. Well, a lot in this class. We're going to talk about polygons. What a polygon is. This is incredibly wordy for something I find very simple. A polygon is an enclosed figure, and all the sides are straight pieces. There's no curvy pieces to a polygon. So all of these pictures on the whiteboard, polygon. Triangle is a polygon, square, rectangle, parallelogram. No curved pieces. That's as wild as that gets. Okay, now, different types of polygons. So you're going to have to know whether it's convex versus concave. I find this description very wordy for something that's very simple. Polygon is convex when no line that contains the side of the polygon contains a point in the interior of the polygon. A polygon that's not convex is concave. That's like clear as mud to me. Concave. A side caves in. Convex. The sides do not cave in. So when you look at these next problems, obviously which one would you say is concaved? Which one has a caved in side? A. I'm like, why do they have to make it so challenging? This would be our convex. Okay, I'm going to flip back to the last slide because it also asked you to classify them by the sides. So that's this little chart over here on the right-hand side. Again, I don't expect you to have all of these names memorized or know them all right now, but you're going to start seeing them, of course, throughout the year. I know you know triangle has 3, quadrilateral. We're going to see some pentagon, hexagon, heptagon for 7, octagon, nonagon, etc. So we are also, let me click it to the next slide here, going to classify by the number of sides. How many sides on this concave polygon? 4. So we're going to call that, we're going to get fancy and call it a quadrilateral. So on your homework, you might just need to keep your notes handy because you're going to need the names of the figures if maybe you don't have those all down quite yet. How many sides on B? 6, so we're going to call it a hexagon. So that's as wild as that gets. We're just gonna start using the names because we're gonna start seeing these figures throughout the year. Triangle, quadrilateral, hexagon, heptagon, those are pretty common. All right, let's get to the calculations. Now, all of these formulas, of course, are on your sheet. They're on the board over there. We know area of a triangle, base height over 2. Just to point it out, height, of course, is right down the middle, always makes a right angle. Because this might be the new one, a parallelogram. We do a whole chapter on parallelograms, people. But for today, you need the height. Right down the middle makes that right angle. Height always makes a right angle, which is important when I'm doing some calculations here. So, find the perimeter of triangle DEF. So perimeter, that's what I'm after. Triangle, let's start plotting the points here and see what we're looking at. So D's at 1, 3, right 1 up 3. Make sure we label. 4, 2, 3 for E, -4, -3 for F. Perfect. Okay, so if we're going to do perimeter, we need all 3 sides and we're going to add them up. Now, I'm going to start you with the easiest side. What's the length of side FE? What's the length of the bottom side? 8. We can just count it. Thank God. Sometimes you get lucky and you can just count them. Like it, like it. Now, the other 2 sides, here's where this kind of gets bad for us. I'm going to do FD next. Of course, since it's on the slant, I can't just try to count, of course, how many squares are in here. I need a more exact number. So here's the worst part of today's lesson. To find the length of that, I'm going to have to do distance formula. Okay, all right. So from F to D, we're going to do our distance formula. I'm just going to label them. And just like in the warm-up, I'm going to punch it in the formula, which again is at the bottom of the board over there on the side. x2, -4, minus x1 squared. y2, -3, minus y1 squared. So punch that in. We're just going to round everything to 1 decimal place today to make our lives easy. I gotta take a look. I can't remember all these numbers. See what you get. The sound of calculator keys, it's so soothing. You should get 7.8. Okay, still working away here. This is a good one. We need the 3rd side. So guess what? We're going to have to do distance formula again because I need to know the distance or the length of DE. It's the gift that keeps on giving here. Okay. So now I'm going to do D to E. I'm going to relabel up here. I'm just going to keep the D, I guess. I'm just going to write over it and then E. So I'm going to do my x2 minus x1, so 4 minus 1 squared. My y2 -3 minus y1 squared. This is the most time-consuming thing you got to do today. Ellie, you want to take your earbud out, please? Thank you. All right, what do we got? Perfect. Brutal. And just when you think we're done, we're not quite done. But we have everything we need. So it wants the perimeter. So I need to add up all the sides. So I'm going to do 7.8 plus 6.7 plus 8. So add up all 3 sides. Final answer. Oh boy, I'm scared to say it. You might need a double parenthesis on it, is my guess. Like I caught that on somebody else's calculator. And then I'm gonna double parenthesis. Let's see. Yep, that's what it needs. Why I don't? That's just the model. All right, what do you got for a final answer? 20?
22.
Okay, I like it. Now, we talked about a little bit in the warm-up problems labeling. I am gonna label on these. I don't love they didn't tell us like inches, feet, meters, yards, whatever. So I'm just gonna put a generic units on it. To me, this is the worst possible problem you have today where you have to do distance formula on it twice. It is kind of time consuming. All right, let's look at the next one. Area parallelogram, that's what this little symbol means. Parallelogram, J, K, L, M. Well, let's start plotting the points. J is at negative 35. K at 1, 5. Oh, I like that. Okay, that's going to be easy to count. L is at 2, negative 1. Negative 2, negative 1. All right, let's attach these. I'll give you a second to get yours drawn. Now, parallelograms, the blue one up here on the board, base times height is the formula we need. Do an area. I'm just jotting the formula down so it's in front of us. Well, I think we can find the base pretty easy. What's the base? 4, just count it. 1, 2, 3, 4. Now, height. I also think we can do pretty easy. The height, remember, is top to bottom, and it makes a right angle. Now, the height, of course, doesn't matter. We're just going to connect wherever, top and bottom on a straight line. I'm going to go right here through the middle. Count it. What's the height? 6. 4 times 6. We got it. No distance formula needed. This is a good one. I'm going to throw a label on it. There's no inches, whatever, so I'm going to use the generic units. Area, though, I'm going to put the squared. So that was a nice one. Sometimes you get a win. We didn't need distance formula or anything tricky on that. Any questions on those? Okay, let's do these final 2 then. Oh man, we got to do area and perimeter. Okay, not very good. But I like the triangle because you can count this side pretty easily and get the length of it. You can do the bottom and get the length. We'll talk about the slanted in a minute. How tall is it? Top to bottom. What do you got for this side? Count it. 6. I like it. Bottom. 5. Okay, you have a choice on how to do the diagonal, the slanted side. I can do distance formula between the points and do it. Or on a triangle, if you know 2 sides and you want to get the third, what theorem can you use? Pythagorean theorem. I think that's quicker personally, and just to review it, that's how I'm going to roll on this one. So I'm going to do 6 squared plus 5 squared equals c squared. And that's going to give you this slanted side. I just got to solve it. I know that's 36. I know this is 25. I'm going to add 36 and 25. And what cancels the squaring? Square root. Punch that in. What's the square root of 61? $7.8. Let's go with. I'm just going to label it. Okay. So next question. Do you have everything you need to find the perimeter of the triangle? Yeah, we're just going to add up the sides. I don't even know if I'd bother writing this. I'd just punch in my calculator. What's 6 plus 5 plus 7.8? Add it up. 18.8. I'm going to put my generic label on it. Units. Got it? Now, oh God, we're still going. It wants the area, but I think we have all the calculations to do our area. So area, remember, base height over 2. Well, what's the base of the triangle? 5. How tall? What's the height of the triangle? 6. So I have 30 over 2. We don't need a calculator for 30 over 2. Units squared. Any questions on that? So same on your homework. You have a choice on either, if you have a triangle, doing distance formula to get the slanted side or Pythagorean theorem. I lean towards Pythagorean theorem just because I think it's less work, but you pick your poison. Let's do this guy. First question, what type of figure is it over here? Parallelogram. We're doing the parallelogram. Okay, so let's of course take a look and see what we can get some lengths of some sides here, because we got to do perimeter and area. Well, I like the top and bottom. We can just count those. What's the top? Bottom. I like when we can just count. Okay. All right. The slanted sides, the left and the right, are the same. We just need to find one of them, and I'll copy it down for the other. So I'm going to work on this guy. Now, you have choices here. Again, choices. You could just do distance formula between 4, 1 and 2, negative 2. Or, just to show you another way to do it, you could make a right triangle and do Pythagorean theorem to get it. Because I can count that this side is 3, this one's 2, and I can Pythagorean theorem to get C. You will get the same answer, whether you do your distance formula or Pythagorean theorem. I'm going to go Pythagorean theorem. I'm going to do 3 squared plus 2 squared, C squared. Because I could pretty much do the left side in my head. 9 and 4, 13. I do need a calculator for this. What's the square root of 13? Which is what you will get if you do distance formula between those points. Now make your life easy. If the right's 3.6, the left is 3.6. They're always congruent on a parallelogram, the opposite sides. We got everything we need. Perimeter. We got to add up all the sides. So I'm going to do 5, the top, the right, the bottom, the left. So we just simply add those all together. What do you got? Everyone will type it in at once. 72. You got it. I'm going to put my label on. Okay, final thing we need, area. Now remember, this is probably our new one, our new figure. You probably haven't seen this parallelogram a lot. So base height over there on a lovely board. I like it. What's the base? 5. And it's on there. What's the height? How tall is the parallelogram? 3. Right there's our height. We've got it labeled. I don't need a calculator. I got it labeled. Got it. So any questions on that guy? So I think the homework's kind of easy, but it's kind of deceiving here. There are a lot of calculations and some distance formula, etc. So I'm just going to go back to the beginning. I am going to grab your homework here for you, because it's going to start like this. It's going to ask you the convex, concave stuff, and it's going to ask you to name it. So